good. So, are we live? I think so. Hello and welcome. I'm gonna go ahead and take a deep breath and continue problem solving. So the problem, then we're gonna whisper now. Hopefully the volume's okay. Super pow. Let's take a quick look. Back with another problem to solve, another problem to work on. So, your task is to calculate a raised to the b modulo 1337, where a is a positive integer and b is an extremely large positive integer given in the form of an array. Oh, no kidding. Okay. Oh, alright. B doesn't contain leading zeros. All the values for b of I are digits, and b is going to be between 1 and 2,000 digits, and a is going to be between 1 and a will fit is a positive integer that will fit in an unsigned integer. I think it's unsigned. Yeah, it's unsigned integer. Or excuse me, signed integer. It'll fit in a signed integer. So this question is kind of interesting. I think this is not really a good question though, because it's I'll tell you why I don't think this is a really good question. The reason why this isn't really a good question is that the power function in the first place is best implemented using sort of the standard power function, the built-in, because there's like a lot of different ways to compute powers, and I think for the most part the more efficient way to do it is to use the built-in, because they kind of like, they tried to make it efficient. There's like a few different algorithms that exist to compute powers, which I don't really know them all very well, but let's just say that they exist. What I would like to do is, I should have done this, huh? Hold on, give me 1 second to get the chat set up correctly here. So what I would like to do is take a look at how can I possibly incorporate the power function here without possibly incorporate the power function here without what's the word I'm looking for? I guess breaking anything, if that makes sense. Yeah, I want it to be efficient, still be efficient enough to work here. There is another idea that here, which has to do with modular arithmetic, where you can sort of do a lot of these calculations, power functions, power calculations kind of quickly. Just thinking what to do. Kind of want to just write a recursive function that'll just kind of handle this correctly, directly. This is a little bit easier because we're using modular arithmetic. Just there's another idea somewhere in here with, again, modular arithmetic, which simplifies sort of multiplication, and I guess in some sense makes this very much easier. Just thinking, how do we do this? I mean, one idea is like, for each digit, we can calculate like a raised to the first, a raised to the 10th, a raised to the 20th, or a raised to the 100th, a raised to the 1000th, etc., etc. We can kind of compute each one of those as we go, and that's just sort of 10 multiplications modulo 1337, and then that's like a constant number of multiplications, and then or 10 multiplications per digit, and then once you have that number, then actually no, it would be at most 20 multiplications per digit you could do, which is not like great, but it's okay, I guess. Yeah, basically you want to count, yeah, we could do it that way. I mean, that's okay. That's not too bad. It's not amazing, but it's okay. Yeah, let's try that. I like that. That's fine. So we're going to have an integer, we'll say current. We'll just say current. I don't know, what do we want to call it? Current power or current digit? We'll just say power of 10. We'll go do it that way, current power of 10. And it's going to start off as A, right? 10 to the 0th is 1, A to the first. And then we're going to say int ret is going to be, start off with A. And we're going to say for, we have an outer loop, auto x in B, or just digit, we'll say. And we also want to, we said the most significant digit. You just see something here in the form of an array. Okay, 1, 0, I think that means 10, so 2 to the 10th, yeah. So the most significant digit is at the front, it seems. 2, 1, 0. Let me just print. I just want to know. Excuse me. Yeah. Okay. It looks like we are gonna want to go backwards. That's sort of like a formatting thing, just like the format of the input. So that's fine. We're going to use, this is kind of interesting, we're going to use iterators that go backwards. And now what we're going to say is, let's start off at 1, I think. Ret, so we're going to say for int I equals 0, I is less than digit, plus I. So if the digit is 0, we don't do anything. Digit is 1, we do it once. Yeah, that should be fine. Ret times equals current power of 10 modulo 1337. Or no, we'll do it. Yeah, we'll do it two lines, right? And then we're going to say for int I equals 0, I is less than 10, plus I, current power of 10, it's going to be times equals itself, and then also modulo equals 1337. So this will, so update result with next digit, and then update current power of 10 multiplier, if that makes sense. Hopefully that makes some sense. I think this will do the trick for us. Something like this. I don't actually know. Okay. Output 8. Really? 2. So current power of 10 is 2. This digit we said begin, end, right? So this should be, digit should be 3. I is less than 3, goes 0, 1, 2. We would multiply by 2. Yeah, so it should be 2. Yeah, this expected is 8. No, we're fine. Okay, and then we had 1 versus getting 0. We said 0, 0, so we didn't do anything for that one. And then we said multiply the current power of 10 multiplier. So then that goes from 2 should multiply, oh, excuse me, I made a mistake. Yeah, that's a mistake. Duh. New current power. Yeah, that's my mistake. Yeah. Okay. Alright, and we could probably go for it. I want to say we can. Let's try these test cases first. I don't want to be too confident, but see, basically this is just some simple, relatively simple. This is some relatively, oh, you know what, actually, this maybe doesn't work the way I think it does. This is some relatively simple, you know what we could take this modulo 1337 first. That should be fine. Yeah. Yeah, this is a, what do you call that? This is just kind of like making use of the modular arithmetic here, which makes this a lot easier to do. Can we submit this? Yeah, it doesn't matter if we do that. We actually should do it here first. Length, yeah. Let's go for it. Just wondering if there's like a test case somewhere that I'm missing. There's got to be something that I don't realize. Invalid test case. Okay. I'm actually like afraid here. Well, A is, yeah, okay, let's go for it. Alright, nice, got there. Okay. Yeah, this is kind of an easy one. This is one of those kind of makes you feel good questions. Apparently I could have done better with the memory usage, but that's, okay, so, alright, you know, great. Great, that wasn't, you know what I'll do? I'll give that a plus because it makes me feel good. Makes me feel like I did something along that. 15 minutes. I spent 15 minutes on that? No! It should have been like 5 minutes. Well, I made some mistakes, right? Alright, let's yeah, well, we could probably pick up another one. That was pretty quick. So yeah, thank you all for watching. I will talk to you soon. Enjoy the rest of your night. Well, actually, I'm gonna pick up another problem. I'll do another problem. But yeah, that was pretty easy. It's pretty easy.